Hello everyone. The topic of our project is the automatic vehicle parking system. My team members are Manish Patil, Sandesh Mandhare, Rituk Painse, and myself. The main causes of the problems faced in car parking systems are the increasing rate of private car usage in urban areas due to the fast growing economy, derelict policies, and other subsidies. Due to this, car parking has become one of the main concerns for transport and traffic management all over the world. The coordination between parking policies and traffic management reveal how parking is becoming a barrier to the thorough traffic operation. It is also responsible for the inefficient use of available resources. Hence, it is necessary to understand the parking choice behavior and actual demand for parking space. The main purpose of this project is to make parking easy for drivers and also the operator who is handling the parking area. The overview of our project is the main parking problems faced by malls, public parking spaces, cinemas, commercial buildings, hospitals, etc. The main purpose of this project is to make parking easy for drivers and also for the operator who is handling the parking area, which results in reduced labor time and efficient and continuous monitoring of the system. The system consists of three major stages. First, user to park the car on the platform properly. Second, the hydraulic lifter, which will move in horizontal as well as vertical direction. Third is the unloading of cars from one platform to the another. The tools used for development in this project are BNR Automation Studio. It is used to write, edit, code, and create HMIs. VNC Viewer is used to connect with the HMI, and UA Expert is used to implement the OPC UA part of the project. Thank you. Next will be explained by Sandesh Mandare.
Thank you, Aditi. In this section, I'm talking about the block diagram by following the same we carried out in our project. At the start, when the car is moved inside the lift conditions are checked. That is a P1, P2, P3, P4, and L1, L2, L3 are set. The P indicates the proximity sensors, and I indicate the load cell as well. After that one, the swipe card validity has been checked. If the valid entry is allowed, then condition are like that one is followed. When the park slot numbers has to put and the slot availability check. If the it's slot available, address is assigned to the rack, and accordingly rack is moved. Uh, then then check then check the start and moving the car a bit. If they are set, then load cell and also the freezer slot as already occupied, and move the rack to the back to the original position as well. And after that one, we show the message that is the car is parked properly in that one. And after all the process is carried out, then we reset the proximity and the load cell sensor as well in that one. Thank you. Next part Manish will carry.
I will talk a little bit depth about the machine, overall machine. First, the user will place his or her card on the platform of the hydraulic lifter and swipe his or her card on the RFID card reader, and then HMI will display whether the card is valid or not, and the card is placed properly or not. Moving ahead, when the car is on the platform, four proximity sensors, as Sandesh told, and three laser sensors, P1, P2, P3, and P4, L1, L2, and L3, are placed to check whether the car is placed properly or not. An animation window will show that the car is placed on the platform, and then in the HMI screen, the user will swipe the card, and the user will given a choice to select one parking slot to place his or her car. Depending on the user's choice, if the parking is occupied, then it will be notified at that display. We have assumed a 3 by 4 matrix, giving every slot a specific address, and thus, as per user's choice, the hydraulic lifter will move on first in the horizontal direction and towards the vertical direction. And the platform will be actuated in the slot direction and will place in the slots platform using a head-on attachment. The hydraulic lifter has two synchronous motors. which will drive the respective axis in vertical as well as horizontal direction. Additionally, a platform is attached to the lifter, which will help in moving the vehicle to its destination. Talking about the hydraulic lifter is based on the Pascal's law for generating force or motion. It states that the pressure change on an incompressible liquid in a confined space is passed equally throughout the liquid in all directions. Hydraulic lifts pull up the car by using a fluid reliant piston mounted inside a cylinder, which is called as a hydraulic ram. It is made up of a tank which contains the fluid, usually a oil, a pump powered by an electric motor, and a tube between the reservoir and cylinder. The pump forces the tank's fluid into a pipe that goes into the cylinder. When the valve is open, the oil will return to the fluid reservoir. When the valve is closed, the fluid flows into the cylinder and pushes the piston upwards. This is how this is how the car is lifted. Once the car is on the intended floor, a control system tells the electric motor to slowly shut the pump. As no more fluid is flowing into the cylinder, the oil that's already inside the cylinder is trapped there, which means that the piston rests on the oil and the car is lifted motionlessly. Ritvik, can you move the slide a bit? So this is a video. Here, when the car gets on the platform, laser L1, L2, and L3 and proximity sensors P1, P2, P3 are charged, like we can see here. The green color indicates the proximity sensors, and the red one indicates the laser sensor. After parking the car in the platform, we are given a choice to select whichever the slot we want to go. Here it is selected as 9. Now the car will go to the ninth slot. Then the car will be placed in the rack. So the working of that is that after that the conveyor and vertical reciprocating platform VRP will start moving toward the assigned position. The conveyor moves horizontally and VRP moves vertically. When the platform reaches its destination, as we see, the VRP will stop and the platform will start moving in an empty parking slot. When it completely goes into the parking slot, the load cell at the bottom activates and it will show slot is occupied on the HMI. After, as we can see here, that slot 9 is selected. And further, when the car is placed in the rack, the load cell will glow. Like this. Moving ahead, after dropping the car in the vertical parking slot, uh, then if we want to move back to its original place, that is towards the ground, the similar process will take place. Now further, Rutvik will continue.
So these are some of the snippets from our project. And now moving on to the benefits of this project. So we come on to the efficiency part. So the parking management system doesn't rely on a man to do the job. Instead, it deals with software, making fewer mistakes. The man at the gate deals with many people at once. We can get tired and even become ill or maybe absent from work. On the other hand, this parking automated software always works. As a result, the level of efficiency increases and you get to deal with parking protocols without issues. Next is faster processes. Having to stand at the gate and wait for a human guard to finish dealing with one person before going ahead can be a daunting and time wasting task. So, what if you could handle your parking protocols yourself and be the determinant of when you enter the building without delay? One of the advantages of parking management system is that you can do this very quickly. Employees can avoid the long queue at the gate every morning and go right ahead to enter the building or make use of the parking space on their own. Next is security. One of the significant advantages of a parking management system is that it provides security. There is a barrier and a reservation feature that controls the vehicles which have access to a place. This way, it can lock out some at certain times if programmed to do so. Increase service. A company with parking lot management software can serve its customers, clients, and workers better. This is because they can reduce the magnitude of stress that comes into parking. Visitors no longer have to worry about driving around to look for space. They get to save petrol and even reduce pollution as there is provision for a place to drive into once the vehicles enter into the buildings. Now we come on to the challenges faced during the project. The first one is the implementation of a two-axis movement, that is the movement of platform in the x and y direction and showing its animation, and also controlling the system using some handheld devices like phone. And these are the future scopes of a project. First is HMI, developing a human machine interface for this project, which we have completed. And the next is warehouse. This same system can be modified and can be used for transporting boxes or components in warehouses. OPC-UA, Open Unified Architecture, is a machine-to-machine communication protocol for industrial automation developed by the OPC Foundation. And the next one is electrical charging. No, so now Manish will explain you the code and show the HMI of the project. Thank you.
So this is the BNR's Automation Studio. In this we have created a file under which a object is created named as SmartP. Moving to the flow of the code, initial part is for the starting or stopping of the whole system. Moving ahead, it is to be checked whether the card is valid or not. As well as we have to check whether the car is parked properly on the platform or not. For that purpose, we have used 4 proximity sensors and 3 laser sensors. Further, we have assigned addresses like A, B, C, D and so on, and load sensors to check whether the car is placed in the desired slot or not. So in total there are 12 different cases for placing the car in the slot, as well as 12 cases for removing the car from the slot and taking it back to the ground. Lastly, there is code for HMI interaction. Now we can see the UI expert interaction with the HMI.
So when the slot is selected or any other function is selected, we can check on OPC UA or UA expert. So for example, if I slot the card into the RFID tag, we can see that here the card is telling us that select the parking slot. So if I put 9 as my parking slot, we can see that the card is now showing us the result as slot 9 is selected, as well as we can see that the ith address is true. So if anyone wants to see the real-time data, by just having the IP address, anyone can check. So this is how our OPC UA is connected with the HMI. We can see the real-time data